Shake Table Lab by Michael Martinez and Charlie Huang. Michael and Charlie made this in a sketch, and it was used to plan out what the building would look like before it was built. We included measurements on how tall the building would be and what the structure would look like. The first and second stories would be 18 centimeters. We also added an idea of what our roof would look like so our tower could be unique. Here, Michael is shown working on the second floor of our building. He is attaching a roof so it can hold the sandbags that will later be placed on our building. Now, Charlie is adding the cross pieces to our building for support. He is also adding a support from the cardboard to the first floor. Doing this will strengthen the first floor, therefore more weight can be placed on the building. As you can see, Michael is now starting to work on the first floor supports. We believe that the support will hold the sandbags up, therefore allowing it to hold more sandbags. Here, Michael is adjusting the paper at the first floor of our building. Doing this will make it so the tower can hold the sandbags without them falling. Here is the tower with the basic measurements on it. The actual finished structure is shown and the measurements. My partner and I compared the size of the tower in our sketch and the size of our finished tower. The first floor was 20 centimeters and the second floor was 15 centimeters. We static tested our building to make sure it'd be okay during the actual shaking. In order to test it, we added 2 sandbags on the first floor and 2 sandbags on the second floor. My partner and I strengthened the base and second floor of our building by adding X's, or cross pieces, to the walls of our building. Doing this will support the sides and will keep the building from swaying. We use triangles because they don't move from side to side, unlike squares. The strongest parts are the first and second floors. Also, the flooring has construction paper that is supported by many straws, therefore keeping the sandbags from ripping the paper. If the sandbags ripped through the paper, the building would fail because you wouldn't be able to hold any weight. The weakest parts in our building is probably the places that hold the sandbags up. Those are probably the weakest because those are the points of highest stress, and the more the stress there is on a straw, the more likely it is to snap or break. Tape is one of the most essential building materials. We use tape to attach straws together so we can make the corners, roof, cross pieces, and almost everything in the building. The extra supplies we received were construction paper for the floors and extra straws for the roof. Construction paper was used so that it could hold up the sandbags and the extra straws so we could build a unique roof. This is the tower at 6 sandbags. It didn't seem to move much. This is our tower at 18 sandbags. It collapsed with only 2 seconds left to go. Here is the XYZ graph. The graph shown here shows the shaking of the tower. The green is the X graph, which represents side-to-side motion. The orange is the Y graph, or Y-axis, that represents forward and back motion, and the blue is the Z-axis, or Z graph, which represents the bouncing of the tower.
So this is our tower. We call it the Trump Tower, and it held 16 sandbags, but I believe it could have held around 20 to 22 if we would have done one thing: added more tape to the cross pieces. I know it sounds simple, but our whole building collapsed because of this one cross piece and the rest. It detached because we did not add enough tape, and if we would have added enough tape, it could have held so much more. Also, I believe that these middle straws were completely unnecessary. They did almost nothing. So we would keep only one and attach the others to make another crosspiece, therefore preventing the building from collapsing sideways, and we could have held even more. I also think that probably the strongest part of our building was the sides and the edges. I would love to thank Mr. C for telling us to do 3 straws there, because if we didn't, it would have collapsed so much sooner. And I would also love to thank my partner, Charlie. I could not have done this without him. Thank you.
So this is our building. We call it the Trump Tower, and it held 16 sandbags. But I'm sure it could have held much more. I think that the way we messed up and the way our tower actually fell, well, it fell sideways, of course, is because these cross pieces right here, we didn't tape them enough, hence leading to the tower falling sideways. And these straws, they also kind of ripped apart because we didn't add enough tape there. And I think that is one of the major reasons why it fell sideways. I also think that these middle column straws did not help at all, since our tower collapsed sideways, not inwards. So I think that if we just left one there, just for good measure, and then took in all these and put them like right here, it would have made 2 more triangles, which would have made our tower much more stronger. I think that's the major thing where we failed. I am very grateful to Mr. Closet for telling us to put 3 straws on the side columns, since that helped a lot. And I think that one of the major essentials for building an earthquake-proof building is the side columns, and I think that you need extra support on those. I think it was really fun doing this, and I really enjoyed the challenge. And of course, I couldn't have done this without my partner and friend, Michael Martinez. Thank you.